So now that we've done area and perimeter of two-dimensional figures, and we've done volume of three-dimensional figures, the last thing to do is surface area of three-dimensional figures. So you still need to know these same three formulas: area of a rectangle, of a triangle, and of a circle, and they're the same that they've been since the beginning of the quarter. And again, you don't have to have these memorized, they will all be given to you, but just remember that these are two-dimensional figures. So these are when they are flat, rectangles, triangles, circles. So we're not talking about 3D yet. Now, the definition of surface area is just the total area of the surface of a solid. And unfortunately, this becomes a little more complicated than volume was. Volume was, here's the formula, plug it in, there's your volume. But surface area is very different. So I have three solids here for us to look at. The first is a square pyramid, which hopefully you can name by now. And I just want us to think about what the surface would be of this square pyramid. So it has a bottom that's a square. So you can think about that square being one surface. So there's one square. And then there's four triangles. So I have this triangle here. That's one. And then I have this triangle here, that's 2. I have the triangle on the back, that's 3. And then I have the triangle over here on the far right side, that's 4. So we have 4 triangles and one square. So the surface area would be adding up all the areas of that. So the area of that square plus the area of the 4 triangles. All of those areas together would give us the surface area. Now the next figure here, if all the sides are the same, it would be a cube, or we could call it a rectangular prism. And we want to think about how many different surfaces there are here. There's 6 of them. So you would say, okay, so this front square here, that's 1, and then the back rectangle there, or square, depending on the measurements, would be 2. And then you have this one over here on the left side is 3. The top would be 4. The right side is 5. And then the bottom there would be 6. So whether they're squares or rectangles, you're still going to be taking length times width. So that's just 6 rectangles there. Now, with the figures that are not polyhedra, so that would be the cones, the cylinders, and the spheres, it gets very tricky. So think about the surfaces here on the cylinder. We have 2 circles. That's the easy part to think about. So 2 circles. This is it's not a cone, it's a cylinder. Uh-oh. Oh, no, we're good. Okay. So this is a cylinder. And the cylinder has 2 circles. Those would be the bases, top and the bottom. But then think about what this area is going to look like. This in here. And it wraps the whole way around. So it does end up being a rectangle. Think about if you were to cut this, or think about like a paper towel tube. If you were to cut it right here and open it up, then it would become a rectangle. And we call that's called the lateral face, but it would really be a rectangle. Okay, so you would think about the surface. The top is, or think about if you have a soup can. The top is metal and the bottom is metal, and if I were to take the label off of the soup can, that label is a rectangle. It would just be laid out, it would be, straight on top, and then it would just meet to make your rectangle. So that's what a cylinder would be. But the surface area is just the total area of all of those surfaces. Now you're going to hear me say net a lot. And a net is just the flattened out solid. So here I have a box, okay? I can think of this as being my length, this is my width, and this is my height, okay? Now if I took that box and cut it along some edges and laid it all out, this is what it would look like. It's like it's unfolded. Like if you took a cereal box and unfolded the whole thing, we could make it flat, and this is what it would look like. This would be the bottom here. And then the back would fold up, the front would fold up, the top, and the ends. That's just called the net. So this part here, that is called the net of the solid. And nets are going to look all different depending on what the shape is. So let's try to think of what these would make if I were to fold them back up. So here I have a square, and if I were to fold in all of these four, think if I could bring them out of the paper here, and fold them up, they would all meet at the top, and this would actually be a square pyramid. So the square on the bottom and then the four triangles on either side makes it a square pyramid. Now this one, think about this. If I were to fold these triangles in and then fold this around it, it's actually going to make a triangular prism. And think about if you go look on the windowsill, number 3 is a triangular prism, and its net would look just like this if I could cut it and unfold it. I'll move down here to this one next. This would be a cube. We have all 6 sides to a cube, and they're all squares. Again, if I would fold it up, it would make a nice little box. And then this one is a cone. This would be my base down here, and then I could fold this right around. And I'm sure you've done this with a piece of paper before. You've made it like a cone. If you fold this right around and have this side here meet this side over there, that would be your base and it would make a cone. So the first way to find surface area is you could find the area of the net. So this, I already have the net laid out. So the net here, if I were to fold this all up, it would make a nice little box. Okay, but it's the net right now. So if I just find the area of all 6 rectangles here, that would actually give me the surface area, because it would give me the area of the entire surface. So we know that the area of a rectangle is just length times width. So to find the area in here, 9 times 3 is 27. The area of this rectangle would be 9 times 4, which is 36. This little one over here, 3 times 4 is 12. Same on this side. This rectangle again, 9 times 3. And this rectangle, 9 times 4. And now to find the surface area, we would just add up all our areas. So 27 plus 36 plus 27 plus 36 plus my 2 little ends, 12 and 12. Gives me a total of 150 square centimeters. We're back to square units because this is area. So area is always squared. We're not going to be cubed anymore. That's just for volume. Now for the next one, they don't give us the net, but we're going to draw it. Okay? So we're going to try and draw the net for this triangular prism. Alright, so if I think about it, I have my bottom rectangle. That bottom is 4 centimeters by 12 centimeters. And then I have the 2 triangles on either side of that bottom, and it tells me that this distance is 6, and this side is 7. Now I have to think about these rectangles. So this rectangle here is this rectangle here. So that's going to be 12 and 12 by 7 centimeters, because this side and that side are 7. So hopefully you can see how I got all of those dimensions. And there's a practice worksheet on this where I give you the solid just like this, and then I have the net drawn out for you, or it's written there for you, and then you fill in the dimensions. So you'll see that in the crate. That's good practice. So now, just like the last one, I'm going to find the area of all these shapes. So 12 times 7 for this rectangle is 84. 12 times 4 inside here is 48. And this rectangle again is 12 times 7, which is 84. Now the triangles. Now remember, triangles are not just length times width. Triangles are 1/2 base times height. So 1/2, the base is 4. The height, they tell us, is 6. So that's going to be 12. Same thing up here. That would be 12. 1/2 base times height. So now to find my surface area, I'm just going to add them all up. So 12 plus 12 are my two triangles, and then 84, 48, and 84 are my rectangles. And that gives me a total of 240 square centimeters. Okay, last one. Now this one's a little hard to see. The copier didn't do a fantastic job here, so it might be a little tough for you to see on your notes. But okay, so first we want to identify the solid given by its net. So this solid, again, is going to be a rectangular. It's not square because my rectangle in there has different side lengths. So it's a rectangular. Oh, that's not good. Pyramid. So those triangles would come up and form a pyramid. So again, I just want to find the area of everything here. So the area of my rectangle is just 6 times 8, which is 48. The area of this triangle is going to be 1/2. The base there is 8, and the height is 14. So that's going to be 56. And that's going to be the same as this one down here. And then the last area here, again, it's 1/2. My base is 6. And my height is 12. And so that's going to be 36. So I have two pink triangles, 36 plus 36. I have two blue triangles, that's 56 plus 56. And then I have one orange rectangle, 48. So my total surface area here is going to be 232 square centimeters. Okay? So this is just an introduction to surface area. It just shows you the basics, what nets are, and one way to find them. There are formulas that we are going to look at because sometimes you can't get the net or you can't figure out what the net is or the measurements or whatever, but if you can use the net, then you can always find surface area that way. I know this is a little bit confusing, so if you're having any trouble, you can watch the video again or feel free to ask me any questions about it.